So guys from the channel, welcome to another video. Today it will be a video just to show a curiosity that happened to me, a bench experience that I was doing here. Recently I was calculating a gate drive here for me to make some small sources switched on for me. So what happens? I wound a toroidal transformer to make the gate drive, and I'm going to show you the wave that is on top of it. This is a tip for you to be careful with the permeability of your core, that sometimes it really looks like a ferrite, right? The material it is composed of can be like or similar to this one. This yellow is the famous iron powder toroid. It is an ATX source output inductor. Everyone knows, it is very famous this toroid here. So for you to make a gate drive with transformers, you have to make it with pure ferrite with a very high permeability 2200-2800, right? Usually those green toroids, or those ferrites like a computer, that is this type of material here. Okay, these are the ideal ones. So I found a toroid that is easier to coil and I calculated my gate drive. It is at a frequency of 47 kHz, everything calculated correctly. There are 3 coils, the input that comes from the oscillator of the SG3525 or TL494 and the 2 outputs that will switch. They are wound in counterphase. The 2 MOSFET or IGT will turn on at the same time and close the short in the switched source, and they are wired in counterphase, but I only coiled 1 output so I can see this wave on the oscilloscope. So it's very important that you have an oscilloscope so you can check the wave before you move on with your project so you can avoid QYMR MOSFET beauty. So I'm going to show you here. You can analyze that it's very similar to a pure ferrite. Really it was removed from the TV line input filter, so I'm going to connect it here now to the battery and you'll analyze the wave there on the oscilloscope that is on top of it. I'm going to show it here. Look, I took it. I'm going to connect it here. Look, you'll see the soft start, that is the soft start, and you'll see how the wave is there. So what happens? You inject this wave into the gate of the MOSFETs or the IGTs that you are going to put. It will be heating up. It has to be as square as possible. Maybe there is even a way for you to reduce this wave here, soften it with a capacitor. It's a circuit with diodes, which is what I'm going to do to improve this wave, because as it is sometimes charged, the core energy cannot escape back. It appears very magnetized. So it gives this distortion. Sometimes it may be a pure toroid, but it looks like this with this distorted wave. So what I did, I took an ATX source transformer that is the EE16, IT is a gate driver too, together that will switch the 13007, which is the half-bridge topology of the ATX sources, and I calculated and made the same scheme. I made the input that would be here and the output that was supposed to have one more output just for us to analyze the wave. So you will see that the wave already changes only with another type of material, so I will disconnect. Here, I will solder to you here for you to be aware. If you mount a gate driver and it keeps heating up the MOSFET, many times it can be just because of the type of material you are using there, right? The soldering was quick here. That's why I don't have the exhaust fan. It's not good for you to breathe the smell of that melted tin because it's carcinogenic and can be bad for your health, right guys? This one I calculated too. Practically it has the same area than this one, so it was almost the same number of turns. So I'll call you and you'll see the wave on the oscilloscope that it's closer to being square. So I called and look how the wave is there. The frequency is what I calculated at 47 kHz. In this potentiometer here I can adjust the frequency, as you can look there, decreasing or increasing. It was calculated at 47 kHz and you can see that the wave, this one, is prettier. It's coming out more or less 13 volts. It was calculated to come out 12 volts around, right? So it's there. Perfect. You can see that it is there at 12 volts, calculated right. So these transformers from the ATX source, the EE16, you can make a gate driver with it for your switched sources so you can have galvanic isolation between the high voltage and the IC, so you can use the IR2110 to make the small sources, which is also very good, but the transformer is better because if the MOSFET is shorted, in the input transistors it will never let this voltage. This high voltage return to the IC since it is galvanically isolated, so this is very important in switching. Power supply, right. So that's it guys, if you liked the video leave your like, subscribe to my channel, follow me on Instagram, the link is in the description of the video there. Big hug, leave your like to strengthen the channel, we are together and see you next time video.